Hello everyone. Here I am going to present a topic on chromatography, which is a large separation technique. As you all know, chromatography is an important biophysical technique and it is used for the separation, identification and purification of the components like amino acids, plant pigments, purines, pyrimidines, organic acids, liquids, etc. And it was first discovered by Michael Sweet in 1906, and he used to separate colored substances from a mixture like plant pigments, and hence the name chromatography. Chromatography, the word meaning is color writing, but now we can separate colorless components also. And let us understand the basic principle behind the chromatography. So, all the chromatographic methods have two common features, namely mobile phase and stationary phase. And these phases are mutually immiscible, and the separation of the components depends on the relative solubility of the substances in these two different phases, that is in the mobile phase and the stationary phase. The mobile phase may be a gas or a liquid, and the stationary phase may be a solid or a liquid. And the sample to be separated is applied at one end of the stationary phase, and then the mobile phase is allowed to move through the stationary phase. And the components of the mixture get dissolved in the mobile phase and are carried along with the mobile phase. So different components of the mixture interact with the two phases differently. That is, within the two phases means within the mobile phase and the stationary phase. But the component which interact more with the mobile phase and less with the stationary phase separates or migrates fast. That is, the higher the solubility of the substance in the mobile phase, the greater will be the rate of movement. And the substances having greater affinity for the stationary phase resist to move and stay behind or separate very slowly. That is, the component which has less affinity with mobile phase but with high affinity towards the stationary phase migrates very slowly in the system. Next, classification. There are different types of classifications, but here I am mentioning the classes based on the phase distribution. And based on the phase distribution, there are two types of classification. One is partition chromatography, there is adsorption chromatography. And this is the most basic classification on the basis of the nature of the mobile phase and the stationary phase. And if we use a liquid stationary phase, it is called a partition chromatography. And phase distribution occurs by partition, and the solute is distributed in between the two liquid phases. Second one is the adsorption chromatography. If we use a solid stationary phase, it is called a adsorption chromatography. That is, stationary phase is a solid adsorbent and it acts as a support that has specific binding sites for the solute molecules. Next, major types of chromatography. Here I am mentioning only three types of chromatography. First one is paper chromatography, thin layer chromatography and column chromatography. First of all, paper chromatography. It's a type of partition chromatography where mobile phase and the stationary phase are liquid. That is, it's a liquid partition chromatography. Here, the stationary phase is a film of immobilized water adsorbed on a special type of filter paper made of highly purified cellulose. That is, here the stationary phase is a filter paper and the water content of this filter paper act as the stationary phase in the paper chromatography. The filter paper contains about 50% of its weight by water. And the mobile phase use these organic solvents like butanol, acetic acid, etc. The apparatus of paper chromatography contains a filter paper, a support for the filter paper, and an airtight glass cylinder. The sample solution to be tested spotted near the lower edge of the paper and then dried. The filter paper is then suspended in the glass jar or glass cylinder with its lower end just touching or dipping the mobile phase. This is the mobile phase, and the sample spot on the paper must always remain above the solvent level. And the solvent or mobile phase moves through the filter paper by capillary action, carrying along with it the various components of the sample. And the separation of the compound of the mixture is caused exclusively by continuous partition between the solvent flowing around the paper and the water held in the paper. After some day, the filter paper is removed and dried. Now we can see that colored components form a number of colors also on the paper, and the colorless components can be there. It is located by spraying certain reagents which can form colored complexes with them, so that we can easily identify. This picture shows various plant pigments which are separated through paper chromatography, like chlorophyll A, chlorophyll B, etc. Second one is the thin layer chromatography. This is a more recent technique of adsorption chromatography, where a suitable adsorbent like silica gel coated over a glass plate or plastic sheet to form a thin layer act as the stationary phase. And the sample to be separated is spotted at the lower side of the dried TLC plate, and the lower edge is dipped in a suitable solvent in a slanting position, just like this. And this is the suitable solvent or mobile phase. The solvent rises by capillary action, just like in paper chromatography, and the compounds of the mixture separate as discrete spots within 1 or 2 hours. So the thin layer chromatographic plate is then dried, and the positions of the separated components are located using certain suitable location reagents. And the thin layer chromatography is more speedy and accurate than paper chromatography. Here, the separated compounds appear as more compact and discrete spots without overlapping. This is the advantage of thin layer chromatography. Third one is column chromatography. It is the simplest form of adsorption chromatography. Here, an inert adsorbent such as alumina or calcium carbonate, etc. are packed inside a glass or steel tube which forms the column, which serves as the stationary phase. The mixture to be separated is dissolved in a suitable solvent like petroleum ether, hexane, benzene, acetone, etc. and is then poured down to the core. So this is the column which is packed with a certain adsorbent that form the stationary phase. Then the mixture to be separated is dissolved in a suitable solvent like petroleum ether, acetone, and is then poured down to the column. And different components of the mixture drain down to the column at different rates depending on their adsorption coefficients. By pouring more solvent, that is mobile phase, the components can be separated and collected one by one, just like this. So these are the major types of chromatographic methods. Next, some of the applications of chromatography. It is among the most selective and widely applicable separation technique, and it is used for the separation of amino acids, proteins, carbohydrates, etc. and used for the purification of proteins, pharmaceuticals, phytochemicals, etc. And it is used to separate active components from plants and used for the analysis of vitamins, drugs and hormones. Used for both the quantitative and qualitative analysis of complex mixtures, and it is used for the determination of molecular weight of proteins. In hospitals, it is used to detect the alcohol levels in a patient's bloodstream through chromatographic methods. In environmental agencies, it is used to determine the level of pollutants in the water supply. So these are some of the major applications regarding chromatography. Thank you for watching.